Right, welcome everyone. Welcome into the third session of our course outline, or of our course. That is our systems design, and today we want to look at what we call system development life cycle and methodologies. But before we look at that, let me just have a quick recap of our previous session. Our previous session, we were looking at what we call the systems analyst, and we said the system analyst, that the person who is responsible for carrying out system-analysis activities, that is data collection, understanding facts, and also coming up with objectives, and then also is responsible for carrying out design activities, that is coming out with the designs, doing the testing, and at the end of the day, he has to fulfill the identified objective, or he has to solve the identified problem during the system analysis activities. We also looked at the roles and also at the attributes of a systems analyst. But today's business, we want to look at the system development life cycle and methodologies. So let's look at what system development life cycle is. Right. The system development life cycle is also called the software development life cycle. That's the process used to develop information systems. We call it a methodology. All methodologies are derived. All methodologies are derived from a logical problem-solving process that is sometimes called the system development life cycle. So the system development life cycle is also called the software development life cycle. So those terms are used interchangeably, whether this as software or the system is one and the same thing. So a system development life cycle, we are looking at a logical system problem-solving process, and it's also used for the development of what? Of information systems. So what is a methodology? The methodology is the physical implementation of the logical life cycle that incorporates step-by-step activities for each phase. Number 2, individual and group roles to be played in each activity, deliverables and quantity standards for each activity, and lastly, tools and techniques to be used for each activity. So here we need to understand the difference between a methodology and the SDLC. So the process used to develop information systems called a methodology, but all methodologies are derived from a logical system problem-solving process that is sometimes called a system development life cycle. So in other words, we are simply saying the execution of the SDLC becomes a methodology. And in this case, we have many methodologies, or we have various ways of which we can actually implement the system development life cycle. So the system development life cycle is just a logical process or a series of steps that can be carried out to develop steps. But how we are going to execute those series of steps that are outlined, to say we have A, B, C, D, how are we going to execute them becomes a methodology. That is now the physical implementation of the logical life cycle that incorporates, number 1, the step-by-step of each phase. What are the steps involved? How are we going to execute each step for each phase? Then we need also to identify the individual and group roles to be played in each activity. Because we have identified, number 1, the activities that involved in the entire process or in the entire physical implementation of the logical life cycle. We need to identify, we know the steps, we need to identify individual and group roles. Also, we need to identify the deliverables. Deliverables, we're looking at the output of each activity. For example, if we have step number 1 or activity number 1, if we execute activity number 1, what is the outcome of activity number 1? It becomes a deliverable. Then we need also to set up quantity standards for each activity. Then we need also to outline what are the tools and techniques to use for each activity. For example, if we are saying activity number 2 is data gathering, what are the tools and techniques that we are going to use for the purpose of data gathering? Are we going to use interviews? Are we going to use focus groups? Are we going to use judge sessions? Are we going to use questionnaires? Now we know the tools and techniques that are used. So for each and every step, we need to identify the individual and group roles, the deliverables, the quality standards, the tools and techniques. Then after that, we could have executed what? The logical life cycle, or we could have executed the system development life cycle. And how we execute it differs And there's different methods, those different ways of executing the logical life cycle, or the SDLC, which are referring to the system development life cycle. It becomes what we call the methodology. Okay, let's proceed. So a system life cycle, that's the logical process by which systems analysts, software engineers, programmers, and end users build information systems and computer applications to solve problems and needs. It is also called the application development life cycle. So it's called the system development life cycle, software development life cycle, or it's also called the application development life cycle. So system life cycle in an organizational process for developing. System life cycle is an organizational process of developing and maintaining systems. So it's also used for what? For developing and also maintaining systems. It also helps in establishing a system project plan because it gives overall list of processes and sub-processes required for developing a system. Like I mentioned in the previous slide, that for each and every activity, we need to understand what are the activities involved, what are the steps involved. We need also to understand which activities are going to be allocated to who, and how much time and resources are going to be what? To be allocated to those activities. All that information, it becomes part of project planning. So a true methodology should encompass the entire system development life cycle. So of course, very soon we'll be looking at the system development life cycle. So a methodology should encompass all the entire system development life cycle. Then most modern methodologies incorporate the use of several development tools and techniques. Of course, we have different tools and techniques that can be used, but at the end of the day, they differ from steps to step. Which activity are we designing? Are we still gathering data? Are we trying to verify facts? etc. So in other words, we can say that various activities put together are referred to as the SDLC, or the system development life cycle. So it also means the term systems analysis and design terminology. The system development life cycle also means software development life cycle or application development life cycle. So what are the phases of the SDLC, referred to as the system development life cycle? These are the stages of the software development life cycle. We have number one, what you call preliminary study. Then we also have number two, feasibility study. Number three, detailed system study. Then we also have systems analysis, system design, coding, testing, implementation, and maintenance. So if you look at these phases, they more or less portray our course outline. You will see that after we are done with these small issues, we're going to be looking at a feasibility study in detail. We are going to be looking at system analysis and design in detail. We are going to be looking at system design in detail, testing in detail, implementation, and lastly maintenance. So it's more like our course outline. Alright, so this is a pictorial representation of the system development life cycle, whereby we start by the system study. System study, we're just trying to acquaint ourselves. We are trying to acquaint ourselves to the system, and that is under study. And after acquainting ourselves, we're trying to figure out the problem through the preliminary study. Then from there, we go on to feasibility study, analysis, design, coding, testing, implementation. So of course, we're going to be looking at each stage, not in that much detail, because later on we'll be looking at all these stages in detail, or maybe they will be representing a unit or a chapter on its own. But for now, just because we want to understand the system development life cycle and the methodologies before we come to look at the entire, like to say what is all involved in design. Now let's look at each phase in turn, and then we go on to look at the methodologies. So we want to look at the phases of the system development life cycle. So the first phase is what we call the preliminary system study. So this is the first stage of the system development life cycle. So, and it's a brief investigation of system under consideration. It also gives a clear picture of what actually the physical system is. So we are just acquainting ourselves with the system under study or the system under consideration. We want to understand what exactly is the problem. Like we mentioned, I think in our first session, we say in analyzing the system, we might want to come up with a new system. We might want to replace the system that is currently there, or we might want to complement. So the preliminary study, it guides us to say, should we come with a new system altogether, or should we replace the system, or should we complement the system? Then I also mentioned, I think that was in our first session, that we might want to replace, we might want to complement, or we might want to come up with a new system. Then we need also to evaluate, because there are many ways of doing so. Of course, we'll be looking at it later on. But all we are trying to do is we want to find what exactly should we do. Thus, under preliminary study, are we replacing? Are we complementing? Are we also coming up with a new system? So, in practice, the initial system study involves a preparation of a system proposal. That is, like we mentioned, a deliverable. We say, it's a deliverable is an outcome from a particular activity. So, from the preliminary study or system study, we come up with what you call a system proposal. That's the deliberation. And the system proposal, it lists the problem definition, what's the problem that you have identified. It also lists the objective of the study, terms of reference for study, constraints, expected benefits of the system, and all etc. And all this will be done in light of the user requirements. Why in light of the user requirements? Because we could have a user, we are not only looking at the user, like user in quotes, or the one who's going to use, but we mentioned about the stakeholders in our previous session. We could have done a bit of stakeholder consultation. So everything that we'll be doing, the problem definition, objectives, terms of reference of the study, will be in the light of the user requirements, or in the light of stakeholders that could have been consulted. So let me just take you a bit back. You are doing it to understand. So by the time you are required to say, come and bring your proposal. Even in real world, you come up with a proposal, you present your proposal to a panel, just like you did when you're defending your proposals under your 200 projects. That's also what happened in the real world. You have to present your proposal, you respond to questions. So it's important that you carry out your preliminary study in a way that you will be in a position to respond to questions when necessary. So who is going to prepare the system proposal? Obviously, the system analyst is going to what? To prepare the system proposal. And the system analyst said will study the system and places it before the user management. Look, like I said, you're going to present the proposal to what? To the user management. So preliminary study is all about acquainting yourself, understanding the system, whatever. Just sorry. Okay, so let's continue on the preliminary study. Then the management may accept the proposal. That is, like we said, the proposal is going to be presented to what? To management. So after being presented to management, then the management, like any proposal, the proposal may be accepted, may be rejected, or may be accepted with modifications. So we expect it either to be accepted, then we proceed to the next stage, that is when it's accepted. It may be rejected, or can be accepted or rejected with modifications. So in summary, we could say the system start phase passes through the following steps. Number one, you need to do what you call problem definition and project initiation. Then you do what you call background analysis, and lastly, you go on to inference or findings. So problem identification and project initiation, you identify the problem, you go on to look how are we going to initiate the project. Background analysis, that's where you need to understand more about the organization. If it's maybe you're doing it for technology, it's maybe for the computer science department or IT department, that's when you go on to check what is exactly that computer science or IT department are into, so that you now try to more of validate or verify whatever you've identified, the problem that you've identified, the background of the organization. And then you're going to document everything, your inferences and findings, and that will be what you call a system proposal. After that, you go on to the next stage, which is what we call the feasibility study. So in case the system proposal is acceptable to the management, the next phase is to examine the feasibility of the system. Okay, the feasibility is basically a test of the proposed system in the light of its workability. We're looking in terms of its workability. Number one, meeting user requirements. Number two, then effective use of resources, and of course, the cost effectiveness. So we want to say we are actually trying to test to see if the proposed system is workable. Is it meeting user requirements? What about the effective use of resources? What about its cost effectiveness? And of course, these feasibility studies can be categorized as technical feasibility. They can be categorized as technical feasibility. They can also be categorized as operational feasibility, economic feasibility, and also as a stage of feasibility. Of course, we're going to be looking at this in our next chapter when we are going to be looking at it as a topic. But basically, we want to see if we have the technical requirements and as well as the technical expertise required to develop the system. We wanted to see if the system has been fully developed and is functional. Are we going to operate the system? Then we're also going to look in terms of economic to say, do we have the necessary funds to implement the system? If yes, if the system is going to be developed, is it going to make any economic gains or any economic sense to the organization that is going to use the system? Then, lastly, schedule feasibility. We are simply saying, given the time resource that we have, the time available, is it possible that we can come up with such a system? If yes, then we can proceed in implementing the system. So the main goal of feasibility study is not to solve the problem, but to achieve the scope. We want to understand the scope of our system. In the process of feasibility, the cost and benefit are estimated with a great accuracy to find return on investment. Of course, when we are talking of return on investment, it falls under economic feasibility. We wanted to understand how much are we going to get after our initial investment. Then it also defined the resource needed to complete the detailed investigation. Then the result is a feasibility report that is the deliverable of this second phase. Is called a feasibility report, which is submitted to the management. Then it may be accepted, rejected, accepted with modifications. Then the cycle proceeds only if management accepts it. So assuming it has been accepted, we go on to the next stage. Now we go on to what we call a detailed system study. Now we have carried out a bit of our feasibility study. We have done we have actually defined our problem. So the detailed system study now is an investigation of the system, which is carried in accordance with objectives of the proposed system. Now it's more a detailed system study. It's more like a validation and a verification process. We have actually defined the problem. We have initiated. We have make our proposal. It has been accepted. We have carried a bit of feasibility. Now we want to dig deep into the problem, into the issues surrounding the problem, to understand more of the problem. So, like I said, it's more of a validation and verification process. So it involves various detailed study of various operations performed by the system and their relationship within and inside the system. So during this process, data are collected on available files, that is document analysis, decision points, and transaction handled by the process system. Now we are getting into the existing system, that is if any. Then interviews, on-site observation, and questionnaires are the tools used for detailed system study. So using the following steps, is to draw the exact boundary of the new system under consideration. Now, we want to keep in view the problems and new requirements. Of course, we identified the problem. Now, we want to keep, if we are still in line, we are still okay, we are still in line with the problem that we identified. Are we having any new other requirements? And we want also to work out the pros and cons, including new areas of the system. So, like I indicated, a system detailed study you could find in most textbooks. They don't include it. They only include it under the system under preliminary investigation. It's just an extension of the preliminary investigation, but it's more like a validation and verification process where we want to see whether whatever we have identified in A or in the preliminary stage is still holding water. Then all the data and findings must be documented in the form of detailed data flow diagrams, or what we call DFDs, data dictionary, logical data structures, and miniature specification. The main points to be discussed in this stage are specification of what the new system is to accomplish based on the user requirements. Like I said, we now want to look at exactly what the user requirements are, and we can actually put them in terms of what we call use case diagrams. Then we need also to understand what we call a functional hierarchy, showing the functions to be performed by the use system and their relationship with each other. Then functional network, which are similar to function hierarchy, but they highlight the functions which are common to more than one procedure. Then we have to list attributes on entities. These are the data types which need to be held about each other. Then, of course, we might come up with a bit of we might want to come up with a bit of entity relation diagrams. Of course, it will be carried out in the next chapter. But basically, with the data system study, we are trying to validate and verify, to say whatever we have gathered, is it a true reflection of the user requirements? Is it a true reflection of the functions to be performed by the new system? Are we not replicating the old system? We are trying to dig deep to understand whether the problem that we have identified is the actual problem. Then from there, we go on to what we call systems analysis. Now, we have gathered a bit of information that we have a bit of verification, but now we have verified to say this is the problem, this is the solution that we want to do. Now we need to proceed to say, of course, that's the problem that we've identified, that's what we want to achieve. Now we need to understand more so that we can actually have a leeway into what exactly we want to achieve, that is the system design. Now, this is now where we are going to collect factual data, understand more the process involved, identify problems, and recommending feasible solutions for improving the system functioning. So, system analysis, it involves studying the business processes, gathering operational data, understanding the information flow, finding out bottlenecks, and evolving solutions for overcoming the weaknesses of the system so as to achieve organizational goals. Now we have the problem. Now we want to understand the business process involved. We're now looking into operational data. We wanted to understand where there are data flows, data loops, data leaks. We want to understand the flow of information. Where are we losing data along the process? We want to find out bottlenecks. Then at the end, we need to find evolving solutions for overcoming the weaknesses of the system so as to achieve what? Organizational data. So we are now, if we have an existing system, normally that's where system analysis is much more important. We are now saying, for example, we want to develop we want to improve the heat library system. We are now going to the already existing library system. We want to see how data is actually collected. We want to see where data is being stored. How safe is it? Then we're trying to see in terms of the processes. We look at them in detail. We analyze them. We have pictorial views of all the flows. We identify where bottlenecks are. And at the end of the day, we are in a position to recommend, to say, we can improve on this one, we can improve on this one. Those improvements are what we are going to implement in what? Under system design. But now we are still under system analysis. Let's finish off with system analysis before we go to design. So systems analysis also includes subdividing a complex process involving the entire system, identification of data and manual processes. In the event that we have a very complex process, of course we're going to subdivide that complex process into sub-processes. Then we look at data flows, data processes, data stores, and we look where manual processes are. All we are doing, we are trying to find areas of improvement. We are trying to find areas of weakness where we can actually improve. Because at the end of the day, we want to come up with something that is going to solve existing problems. We don't want to have a replication of the already existing system. So the major objectives of analysis is to find answers for each business process. What are the answers we want to find for each business process? So how is it being done? Number one, how is it being done? What is being done in the first place? Then number two, how is it being done? Who is doing it? When is he or she doing it? Why is it being done, and how it can be improved? So if you look at this one, what is being done? We are capturing, for example, each library. We are capturing a book that is going out to the library. How is it being done? Are we capturing it manually? Are we scanning the code? Are we taking the ISBN number of the book, writing it in file and store it somewhere? Who is doing that? Is he qualified? Is he a trained person? When is he doing it? What time are those processes being carried out? Why is it being done? And how can it be improved? Those are the objectives or questions that analysis seeks to answer. Then it is a more of a thinking process and involves the entire creative skills of the systems analysis. So we talk of our creativity on the side of the systems analysis. That's where creativity also chips in here. So analysis tries to or attempts to give birth to new efficient system that satisfies the current needs of the user and is a scope of future growth within the organizational constraints. Okay, like I mentioned earlier, to say we don't want to have the same system or a replica of the existing system or another version of an existing system. So the goal of analysis is to give birth to a new efficient system that caters for user needs and also that caters for future growth within the organization. So the result of this process or the deliverable of systems analysis is a logical system design. And you must also note that system analysis is an iterative process that continues until a preferred and acceptable solution emerges. So in other words, we are simply saying we can actually go again and again until we have a refined objective, until we have a refined system that is working properly, until we have a system that meets user requirements, until we have a system that caters for the growth of what? For future growth within the organization. All right, so we said we say for preliminary study we said the deliverable is what? Is the system proposal. Then the feasibility report is the deliverable for system feasibility. Then there's a logical system design. That's the feasibility for systems analysis. Now let's move on to system design. So basically, design, we are now converting the logical system design that is as a result of what? Of analysis into a physical design. That's all about design. We are now converting the deliverable from the previous stage into a physical design, which means now the deliverable for system design is what we call a physical design, which is a conversion of the logical design into a physical design. But so what is system design all about? So based on the user requirements and the detailed analysis of the existing system, the new system must be designed. That's why we call it the design phase. And that's the most crucial phase in the development of system. So we are now converting the logical system that has been derived as a result of system analysis is converted into what? Into physical system design. And design, normally it proceeds into two stages. The first one is what we call preliminary or general design. And under this one, the features of the new system are specified. The cost of implementing these features and the benefits to be derived are estimated. If the project is still considered feasible, move to the detailed design. So it's just like we're having a sketch design of what we want to have. Then we have a sketch of rough estimates of cost, the features and the benefits. If it's feasible, that's when we move on to the structured or detailed design. So at this stage, that's where we start computer-oriented work. So the design, they become more structured. So the structured design is a blueprint of a computer system solution to a given problem, having the sum components and the interrelation among the subcomponents as the original problem. Input, output, database forms, codification schemes, and processing specifications are drawn up in detail. So now we are fully aware, we are fully satisfied to say, of course, that's the system that we want to do. Now we want to come out with our input forms, output forms. We need to understand our entities, their relationship. We design our databases. We need input, output forms. Then we also come up with codification schemes, then processing specifications. Now that's when, if for your 400, I think this is the chapter 4 or chapter 5. That's when you will be doing the design for input, for login form. It's like this. For capturing the user requirements, we need a form like this. Everything that's now being put in what? In a language that the computer understands. So in the design stage, the programming language and the hardware and software platform you need the new system will run are also decided. Now you need to know which hardware which the type of hardware that you use, the software that you want to use, then the programming convention that you want to use is also going to be designed. So there are several tools and techniques used for describing the system design, and these tools including the flowchart, data flow diagrams, data dictionary, structured English, decision table, decision trees. Then, of course, we are not going to be looking at all of this because some of them are old enough. But I think flowcharts, we're going to be looking at data flow diagrams, of course. Then we're also going to be looking at use case diagrams. We're also going to be looking at, what else? Class diagrams. We're also going to be looking at activity diagrams, sequence diagrams, etc. We're going to remove decision tables, structured English, data dictionary, and decision table. I think if you check our course outline, we are going to see the tools that we are going to be using for the purpose of design, of which each of the above will be discussed later in the next lessons or in the next sessions. But I refer you to the course outline. Go and look at the tools for the design. Those are the ones which are going to use. So basically, design involves defining precisely the required system output, to determine the data requirement for producing the output. So with the defining the required system in output, then we need the data requirement for producing that is the input that is required for us to get the output. Medium and format of files and databases, we need to determine that. Then devising processing method and use of software to produce output. Determine the method of data capture and data input. Then we need to also design of input forms, design codification schemes, detailed manual procedures, and documenting the design. So basically, that's what we'll be doing. What we'll be doing through the design phase. But basically, in short, we are simply saying we want to design input and output. Then we need also to design our databases. We need to design codification schemes. How is data going to be processed? Then we need also to look at the database itself. How is it going to communicate with codification schemes, and as well as input and output forms. Okay, fine. Now we have everything. The next phase is what we call coding. Coding, we don't need to talk much more here, but we are just converting the output. Or maybe before that, the output of a system design is what we call a physical system design, which is that's the deliverable of system design. Now we are taking the physical design into the design which the computer understands, or we are converting it in using a programming language. So those programs are the ones that are going to coordinate the movement of data, control the entire process in the system. I'm sure all of you are programming. I don't need to waste our time here. Then the next phase is what you call the testing. After the codification has been done, the system has been implemented, it's now accepting input, does the processing and giving out output. We need to do a number of tests, or to run a number of tests on the on the system. So testing is an important phase of a success system. Then after codifying the whole program for the system, a test plan should be developed and run on a given set of test data. The output of the test run should make the expected results. So if we input A to the system, if we expect B, the system must give B. Then also the output of the test run should make expected. That's sorted for the repetition. Sometimes system test is considered as part of implementation process. Using the test data, the following tests are carried out. There is what you call program test. Program test normally is done during what? During programming. You write to program maybe to add 2 numbers. You test whether it's adding 2 numbers. Then there's also system test. After all the modules have been integrated, you test the system. There's also integration test. You test the different modules are whether they are integrated together. Module A, B, C, D, how are they integrated? Then there is end user acceptance testing to test if user are able to accept and use the system. So of course there are a number of tests. We are going to be looking at testing in detail like I mentioned before. But for now, these are the tests that we are much more concerned that will be carried out on our systems. Then from there, after successful test, particularly the user acceptance test of the new system, the implementation phase begins. So implementation is where theory is turned into practice. The major steps involved in this phase is number 1, acquisition and installation of hardware and software. We need to have acquisition and install the hardware required. We need to conversion. This conversion, how are we migrating from the old system to the new system? Or let me just check if I got that one. Okay, it's here. Okay, fine. Then you need also to train your users how to use the system. And lastly, you need to document the system. Okay, under acquisition of hardware and software installation, it's not that much. Then conversion, I'm going to be looking at conversion. User training, that's not much. Then I also look at documentation. Let's look at all right. So under conversion, we are looking at we're having our old files, be it hard copies, or we've been using an old system. How are we going to shift from the old system or from the manual system to the computerized system? How moving from either manual or an old computer system to the new system, we call it changeover, and we have or we call it conversion method or changeover methods. So there are a number of strategies that can be followed, which number 1, direct changeover, parallel changeover, phase changeover, and lastly, pilot changeover. All right, I'm sure this is part of your assignments. By direct changeover, parallel, phase, and pilot, I think it's part of assignment we're going to be looking at. But maybe just a quick one. Direct, we are rightly discarding the old system and start using the new system. It has its advantages and disadvantages. It's up to you to go and research or not. Then parallel, we have both systems running at the same time. We only discard the old system when we are sure that the new system is up to standard. First changeover, we are making changes in terms of phases. Normally it's done by removing maybe the first phase you implement, the next phase you implement until the system is fully implemented. Then pilot changeover, it's done maybe in organizations normally which are distributed in nature. For example, if you look at OK or Thames Zimbabwe, they can say we want to implement the new system maybe in Chinhoyi branch or Harare branch. Once the Harare branch we are satisfied with the results, we can actually implement in all other branches. But for you, I just want you to go and look at this in detail. What are the advantages to advantage of each changeover or conversion methods? Then for the documentation, there is what you call the user or opera documentation and the system documentation. You go and read what these are all about. Then the last phase is maintenance. Right, maintenance is necessary to eliminate errors in the system during its working life and to tune the system to any variations in its working environments. It has been seen that there are always some errors found in the system that must be noted and corrected. So it also means the review of the system from time to time is important. So till the review the system is done to knowing the full capabilities of the system, knowing the required changes or the additional requirements, studying the performance. So maintenance either is corrective, adaptive, or whatever. Either we want to correct something, we want to keep the system adaptive to changes in the environment. So in the event that a major change is needed, a new project may have to be set up to carry out the change. The new project will then proceed through all the above life cycle phases. It has gone to do through all these phases. All right, so Now let's look at methodologies. Let's look at methodologies. All right, can I pause for a minute? All right. We said the actual implementation of the SDLC, it becomes a methodology. So we have all these methodologies that are listed here, number 1 to 14, and they are not only limited to number 1 to 14. We have a lot of them. So what I'm gonna do here is what should I do? All right, I want you to all right, okay, fine. I just want you to be in a group of 4. I think you're around 4 to 6. Then you pick whatever topic that you want to pick. I'll just come to I'll just try to see what I can do. Or I'll talk to class, but I want you to be in groups of 4. You pick whatever methodology that you want to do. Then after picking each methodology, you make a presentation. For example, if it's a spiral model, you tell us what is a spiral model. You give us a diagrammatical representation of it. Then you tell us the advantages and disadvantages. You tell us where it's most applicable. Then after preparing your presentation, I want you to do a video recording. I think if you go to NetTeams, that software that I'm using to record, you do a video recording. After the video recording, you sent the video recording to my inbox. So I don't know what can I do. Okay, fine. I will just pick names. Then I allocate, you choose your friends. Then you come up with this. So I'll just pick names from the group. Then I'll just allocate names. Then I'll send it via our WhatsApp. And if I give you a name, it doesn't mean that they are one who's going to present. I'll just allocate a name. Then you find your colleagues. Then you prepare the presentation. You also prepare a PowerPoint. You send the PowerPoint and the video to my email, or go to hi.ac.zw, or in lowercase. I think I'll communicate this. And I want this information by Friday next week. So I think it's all said and done. We are done with the SDLC and methodologies. All right, thank you. See you next session.